The Coastal San Luis Resource Conservation District has supported natural resource conservation in coastal San Luis Obispo since 1953. Through partnerships with local land managers, ranchers, and farmers, the RCD has been able to develop and implement sustainable, innovative, and effective conservation projects that have restored habitat for sensitive species, improved water quality and soil health, and helped farmers and ranchers improve the resilience of their working lands. Efforts include restoration projects on every coastal watershed in San Luis Obispo County, remediation of Oso Flaco Creek, on-farm water quality improvements across the county, healthy soils demonstration projects, and a large-scale dune habitat restoration program on the Oceano Dunes State Vehicular Recreation Area in partnership with California State Parks. California State Parks approached the RCD in 2012 with an opportunity to support the development of their dune habitat revegetation and restoration program in the Oceano Dunes State Vehicular Recreation Area, or ODSVRA, located in coastal southern San Luis Obispo County. The ODSVRA sits within the Guadalupe-Napomo Dunes complex. For thousands of years, this area was seasonally inhabited by the native Chumash tribe. They would move into the area to fish, hunt, and forage for clams. Through the 1890s, the dunes were used as a combination of livestock grazing land and open space until Oceano was formed and recreation expanded. In the 1900s, the dunes became primarily a recreational destination, though during this time they also housed the artistic counterculture Dunites, military installations, and private parcels for oil drilling. Vehicle use increased here as off-road vehicles became more common, and the Off-Highway Motor Vehicle Recreation Program was created in 1971 to find the necessary balance between visitor recreation, private ownership, and natural and cultural resource protection. Today, this program is handled by California State Parks. Although a large portion of this dune habitat is used for vehicle recreation, California State Parks oversees a number of natural resource programs that protect sensitive species and restore dune habitat. In response to air quality concerns around the park, California State Parks has been implementing a vegetation restoration program as a natural, sustainable way to prevent negative impacts of park conditions on air quality. Since 2012, the RCD has helped state parks to implement this program by assisting with annual restoration activities. The Guadalupe-Napomo Dunes Complex is the second largest dune system in California, stretching along 18 miles of coastline and encompassing roughly 22,000 acres of unique coastal dune habitat. A series of freshwater lakes is also found among these dunes, including Oso Flaco Lake. As such, the area has been recognized as a National Natural Landmark, and a large portion of the ODSVRA has been set aside for conservation. This dune ecosystem hosts a diverse range of plant and animal species, a number of which are state and federally threatened or endangered. The coastline provides nesting habitat for the western snowy plover and California least tern. The westernmost dunes, or foredunes, contain threatened plants like beach spectacle pod and surf thistle. Dunes that lie further east, or back dunes, host the small endemic population of the endangered Napomo Mesa lupin. In the easternmost brackish marshes and wetlands, you can find the endangered Gambel's watercress and La Graciosa thistle. In addition to state and federally listed species, thousands more plant and animal species depend on this unique dune ecosystem to survive. A combination of factors, including vegetation reduction, vehicle disturbance, and climate change, are not only contributing to the loss of this unique habitat, but they also threaten public health. Increased winds and ground disturbance, paired with decreased vegetative cover, allow fine particulate matter called PM10 to mobilize into the air. This creates hazardous air quality conditions for adjacent residential communities. In an effort to mitigate this impact, as well as protect dune habitat biodiversity and increase resilience to the changing climate, State Parks and the Desert Research Institute developed a dune revegetation and restoration program. This restoration program is science-driven, and it operates year-round, beginning with wind studies conducted by the Desert Research Institute to identify areas with high PM10 emissivity. RCD and state park staff then install windblock fencing in some of these areas. Ideally, this fencing should dramatically slow sand transport and reduce PM10 emissions from that site. In order to test the efficacy of each wind fencing site in this goal, sand collectors called BSNEs are also installed throughout the areas. They are monitored following periods of high winds in order to determine how much sand movement occurs. This helps the involved agencies determine which areas should be further stabilized through restoration. Wind fencing is a useful, though static, sand stabilization tool. In order to permanently and sustainably reduce PM10 emissions, dynamic, adaptive vegetated dune systems need to be established. The sites where wind fencing appeared to be most useful are prioritized, and site-specific restoration plans are developed. In addition to restoring bare sand sheets based on this process, some struggling portions of otherwise stabilized vegetated dunes are touched up or supplemented to get them back on track. Dune restoration is a labor-intensive, multi-step process, beginning with native seed collection, followed by native plant propagation, site preparation, planting, and finally, seeding. Seed collection typically begins in late spring. Native seed is collected exclusively from within the park in order to maintain the genetic integrity of the species populations here. Although these same species may exist elsewhere, the plants within the park are adapted to the salty soil and sand, winds, and low nutrient and water availability of the coastal dune environment. Seed purchased or collected from elsewhere would not be similarly adapted and may not be as resilient to the harsh conditions here. Hundreds of pounds of native seed are responsibly and sustainably collected from the field for use in propagation field restoration. Native plant propagation begins in mid to late spring, using seed saved back from the previous year. At the State Parks greenhouse, RCD and State Park staff propagate plant numbers based on the site-specific restoration plans developed for the year. Of important consideration for each project are the desired density of plants per acre, as well as the relative proportions of each species. The typical palette includes species that are known to quickly stabilize the bare dunes and pave the way for ecological succession into a fully functioning, stabilized vegetated dune. The proportions of each species are based on the type of dune environment and the ecological function they serve within it. 4 dune plants need to be adapted to the harshest environment here. They will experience salt spray and wind, salty sand, and frequent burial. Common species here include dune primrose, beach burr, and sand verbenas. Previous restoration staff have struggled to grow sand verbenas from seed, but in 2019, we developed a promising method of selecting viable seeds, removing them from their pods, then scarifying and sowing the viable seed. Back dune species are adapted for a more stable environment with less burial, wind, and salt spray, but they still have little access to nutrients and water. Species here include nitrogen fixers like silver dune lupin and deerweed, whose residual biomass provides nitrogen for other plants establishing in the area. Also present here are yarrow, Blockman's groundsel, Blockman's leafy daisy, and coastal buckwheat. In order to propagate the total number of plants needed for a restoration year, additional nurseries are contracted. Cal Poly is currently growing under a multi-year contract with state parks, and annual contracts are drafted between state parks and other local greenhouse operations. The plants are nurtured and monitored in the greenhouse until they're ready to be planted. But before the plants can be put in the ground, steps must be taken to prepare the restoration sites. Site prep involves shaking out a thin layer of straw over the project area to stabilize the underlying sand, prevent sand movement, and retain moisture. Straw clumps are strategically pushed into the eastern side of slip faces as a temporary stabilization measure, preventing the slope from moving so quickly eastward that it would cover newly restored area. Once straw has been put down, the plants are transported to the restoration site for planting. Each plant serves a specific function and is strategically installed on the project site. Branching phacelia and dune mint, for example, are planted near slip faces because they do well with low amounts of water and they're particularly resistant to burial. Silver dune lupin, due to its nitrogen-fixing function, is planted commonly and evenly throughout the area as a supportive backbone. Beach burr and sand verbena are important components of the 4-dune ecosystem, but they're planted far enough away from one another that they can form the distinct hummocks observed in 4 dunes. Once all the plants have been installed, the native seed that was not propagated is mixed with triticale and granular fertilizer and broadcast evenly across the restoration sites. Triticale is a sterile wheat species that functions in sand stabilization. Its roots quickly shoot out to immediately stabilize the sand, and then when it dies out at the end of its season, the roots continue to provide structure for the establishing natives. The straw that was laid out prior to planting helps to capture and protect the broadcast seed, and it protects infant plants from harsh winds. Given time, these restored sites develop into self-sustaining, vegetated dune habitats that change with the natural shifting of dunes over time. As a result of these projects, wind erosion and dust emission studies have shown a marked decrease in fine particulate matter emissions from the park. Restoration also increases the resiliency of the dune ecosystem to the effects of climate change, such as intensified weather patterns and rising sea levels. Restoring this cover also provides habitat for the many animals that depend on it. The benefits of the restoration and enhancement of this unique and biodiverse coastal dune ecosystem are far-reaching, beyond a simple public health concern. These large-scale restoration projects are in part made possible by our partnerships with the California Conservation Corps and the American Conservation Experience. Crews spend several weeks each fall and winter supporting site preparation and planting activities, and they're essential to the success of the restoration program. Working on this project provides these crews with valuable hands-on conservation experience that can further their careers and job or schooling opportunities, and gives the RCD the opportunity to interact with fresh minds in the field of conservation. Since RCD's partnership with state parks began in 2012, the RCD restoration staff has helped to revegetate over 250 acres of dune habitat. This partnership between the RCD and state parks has also resulted in a robust restoration program that has demonstrated effective techniques for adaptive habitat restoration, has increased the knowledge base for dune restoration, and has created a replicable model for future restoration of coastal dunes. The massive scale and success of this continued restoration effort would not be possible without the partnerships highlighted throughout this presentation. The Desert Research Institute has provided innovative and science-based research monitoring to ensure the efficacy and relevance of restoration. California State Parks has continued to support the needs and the objectives of the program, and in recent years, Cal Poly, Greenheart Farms, Clearwater Color Nursery, and Cal Seedling have all provided high-quality native plants. The California Conservation Corps and the American Conservation Experience crews continue to demonstrate the value of community service and the lasting impact of hands-on experience. Thank you to each of these partners that have contributed to the success of this program.